So for the last set of formulas that we're going to cover in these lectures, we'll talk about the sum to product and product to sum formulas. And they do what the name tells you. They let you convert a product into a sum and vice versa. So the formulas for product to sum are shown here on the whiteboard. And as you can see on the left-hand side here, you have a product of trigonometric functions. And on the right-hand side, you have a sum. And in some cases, this might be useful. Sometimes you need to go back and forth between either, and then you can use these formulas. So there's 4 of them. It would be a bit tricky to derive all of them in the frame of the course, but I can tell you that all of them are derived from, and if this was in-person class, you would all shout by this point, the addition, subtraction formulas. Because as we already talked about many times before, these are very powerful formulas and you can basically derive anything from them. So let's do one of these together. Let's take number 3. And what I'm going to do is I'm going to start from the right-hand side, cosine plus cosine. Alpha minus beta, and now I'm going to use the addition subtraction formulas twice. So this becomes cosine alpha cosine beta minus sine alpha sine beta. So that's basically this term right here that I've expanded. And then we have plus, and now the other term, cosine alpha cosine beta plus sine alpha sine beta. So that's this term right here. And so now what does that equal to? Well, you see that this term cancels against that term, and we're left with 2 times cosine alpha cosine beta. And now if we want to really write this the same way as it's written on the right hand side, we can divide by 2 and we get cos alpha cos beta is 1/2 cos alpha plus beta plus cosine alpha minus beta. The other expressions you can derive exactly in the same way, just by using the addition subtraction formula. So before moving on, let's do a simple example. So what I want to do here is I want to express sine 3x sine 7x as a sum of trigonometric functions. And of course, for that I can use my product to sum formulas. And in particular, I have sine times sine. So for that, I'm going to have to use my 4th formula. So use formula number 4. Sine 3 times x sine 7x is 1/2 of cosine of the difference, so cosine of minus 4x, minus cosine of the sum, so 3x plus 7x, that's 10x. And now we can simplify just a little bit more. This is cosine 4x because of the even odds property. So this whole expression then becomes 1/2 cosine 4x minus cosine 10x. So with that, we're almost at the end. We just have to cover the inverse, so the sum to product formulas, and these will take a sum or a difference and turn that into a product. The derivation here is easier than the derivation of the product to sum formulas. Just have to be a little bit clever. So we'll again derive one of the formulas together, and I'll let you do the other ones by yourself if you want to. So what we'll do is we'll introduce two new angles. So set theta equal to alpha plus beta over 2 and phi equal to alpha minus beta over 2. And so note, between parentheses, note that theta plus phi is alpha and theta minus phi is beta. I'm going to use that. And now we'll derive expression number 1, let's say. Here, derivation of number 1. So take 2 times sine theta cosine phi. Now we can use our product to sum formulas and we can write this as sine theta plus phi plus sine theta minus phi. So, and now we know that theta plus phi, that's alpha, so we have sine alpha here plus theta minus phi, that's beta, like this. And now let's rewrite that a little bit by dividing everything by 2. Or actually, no, let's not divide by 2, let's just write it out in full in function of alpha and beta. We get sine alpha plus sine beta is 2 times sine, and now theta here is alpha plus beta over 2, and then cosine of phi, and phi is alpha minus beta over 2. And that gives us our first expression. And now, as a quick last example, we'll prove that sine 5x minus sine 3x divided by cosine 5x plus cosine 3x is equal to tan of x. So a very complicated expression, but basically what it boils down to is just the tangent of x. In order to do that, well, let's look at the numerator first. Sine 5x minus sine 3x. For that, we can use our rule number 2 here. We get that this is 2 times the cosine of the sum of the two angles divided by 2. So 5 plus 3, that's 8, divided by 2, that's 4. 4x. And then the sine of the difference, so 5x minus 3x, that's 2x, divided by 2, that's just x. And the denominator then, cosine 5x equals cosine 3x. And for this, we have to use rule number 3. So here we have 2 times cosine of the sum, again, divided by 2, so that's 4x. And now here we have to take cosine of the difference divided by 2, so that's cosine. And so if we divide the numerator by the denominator, we get 2 times cosine 4x sine x divided by 2 times, again, cosine 4x cosine x, and that's equal to tan of x. And that's what we wanted to prove.